In January 1913, one of the greatest mathematicians in England opened a letter from India. At first glance, it looked like the work of a crank. Pages of equations, no proofs, no credentials, no institutional affiliation, just a name, Srinivasa Ramanujan, and an address in Madras. Hardy set it aside. Then he came back to it. A few hours later, he and his colleague Littlewood were still at the table, working through the results one by one, arriving, slowly, at a conclusion neither man had expected. This was not nonsense. This was, Hardy would later say, the work of a mathematician of the very highest class. But here is what tends to get left out of that story. The man who wrote that letter had spent his entire life in a particular kind of solitude. Not the solitude of being alone, but something harder to name. The loneliness of carrying something of vision, a way of seeing that the people around you simply cannot access. You can speak, they can hear, but nothing crosses the distance. Srinivasa Ramanujan knew this loneliness from childhood. He was a self-taught mathematician from a small town in southern India. No university degree, no formal training, no colleagues who could follow where his mind went. By the time he died at 32, he had filled notebooks with thousands of mathematical formulas, many of which mathematicians are still working to understand. Verify. Status of unproven Ramanujan work. He found people who could recognize what he was doing. Hardy was the first. And even Hardy, perhaps best equipped of anyone on earth to receive what Ramanujan carried, could not fully understand the person behind the mathematics. This is not a story about mathematical genius. It is a story about what it feels like to see things no one else can see, and to spend your whole life wondering if any of it is real. We tell stories about exceptional people in a particular way. We say, they struggled, they persisted, they were eventually recognized. The recognition arrives. The story ends meaningfully. Ramanujan's story does not quite follow that shape. Recognition did arrive. Cambridge, the Royal Society, Hardy. And still, whether he felt truly understood is something we cannot know. That gap between being recognized and being understood, between people knowing your name and people knowing what it feels like to be you, is one of the most invisible forms of human suffering. Most of us will never produce mathematics that reshapes human knowledge. But most of us know what it is to feel that the truest thing about us lives in a place no one else can enter. That is what this story is about. Kumbakonam, Tamil Nadu, late 1880s. A small town on the banks of a sacred river. Temples on every corner. The smell of incense and river water. A world organized around ritual, obligation, caste. Into this world, a boy arrived for whom mathematics was not a subject. It was the only language his mind spoke naturally. Not because someone taught him, not because someone encouraged him, because he could not help it. By the time Ramanujan was 10, he was asking questions his teachers could not answer. By 12, he had worked through an advanced trigonometry textbook not assigned to him, borrowed, and begun finding his own theorems. Verify. Likely, Loney's trigonometry. At 13, he independently derived the formula for the sum of a geometric series, a result mathematicians had established centuries before. He had not been taught it. He had simply noticed a pattern and followed it to its end. His teacher had no way to explain what had just happened. He was not a prodigy in the way prodigies are usually recognized, performing feats that adults could evaluate and applaud. He was doing something stranger. He was going somewhere adults could not follow. And when you go somewhere no one can follow, the natural response of everyone left behind is to assume you have simply gotten lost. His mother believed her son had been blessed by the goddess Namagiri. Verify. Namagiri. Devotion Komalatamil. Ramanujan came to believe it too. In later years, he would say that equations came to him in dreams, that the goddess herself revealed them. He would wake in the darkness, reach for paper before the vision disappeared, and write down what he had seen. He was not speaking metaphorically. What does it mean to have a mind that generates truth through a process you cannot fully explain, even to yourself? At 16, Ramanujan found a book that changed the direction of his life. G.S. Cars times synopsis of elementary results in pure and applied mathematics times a dry compressed list of around 5,000 mathematical theorems, most without proof. Verify. Number. For most students, a reference tool. For Ramanujan, an invitation. He worked through every theorem. He reconstructed the missing proofs, and in doing so, began extending the mathematics finding results Carr had not included because Carr had not known them. This left him alone inside his own work. He had learned mathematics not from teachers but from a list of results tools without context, bricks without a blueprint. He would spend years rediscovering theorems European mathematicians had proven decades before, and years finding results no one had found yet, often unable to tell which was which. And the way he worked made it stranger still. Other mathematicians built proofs like scaffolding, each plank placed carefully before the next. Ramanujan often simply arrived at the result, complete, correct, with no working shown. 7, 7, 7, 7. As if the distance between question and answer did not exist for him. By the time he was 20, his notebooks contained close to 4,000 results. Verify. Approximate number. Formulas. Series. Identities. Many unlike anything in existing literature. 2. Not one published. He failed his college examinations twice. Consumed by mathematics, he had neglected everything else. History, English, physiology, lost his scholarship and had to leave. Verify. Kumbakonam Government Arts College. The second attempt ended the same way. By his early 20s, Ramanujan had no degree, no income, notebooks filled with mathematics no one could evaluate. He had a wife, Janaki, married in an arranged ceremony. Verify. Approx. 1,909. A mother who watched over him with devotion and anxiety. He tried to show his work to mathematicians in India. Some recognized something extraordinary. Others were uncertain. There is an image from those years that is difficult to shake. Ramanujan carrying notebooks through the streets of Madras, looking for anyone capable of telling him whether the mathematics was brilliant or meaningless. Verify. Kanigel. Biography. Not because he wanted fame, because he genuinely did not know. What if the mathematics was real and still no one ever truly understood it? What if you spent your whole life producing something of extraordinary value, and the world simply lacked the capacity to receive it? This is not the fear of failure. It is something quieter and colder. It is the fear that you exist in a register that other people cannot hear. In 1913, Ramanujan wrote letters to mathematicians in England. The first two received no reply. Verify. Recipients. The third went to G.H. Hardy, one of the most respected pure mathematicians in Britain. Meticulous, unsentimental, committed to rigor above everything. The letter arrived on the 16th of January, 1913. Verify. Exact date. Roughly 120 results. Theorems. Series. Formulas with no proofs. Verify. Approximate number. Hardy's first instinct was suspicion. This looked like exactly the kind of letter Crank sent. He set it aside, then came back, then showed it to his colleague, Littlewood. The two of them spent several hours going through the results. Some were known. Some appeared wrong. But some had no explanation in any mathematics either man had encountered. Hardy later wrote that these results must be true, because no one could have had the imagination to invent them. Verify. Wording. This was not a crank. This was someone operating at a level Hardy could barely follow. He wrote back immediately. He wanted Ramanujan to come to Cambridge. For the first time in his life, Ramanujan had found someone who could not only see what he was doing, but who was stunned by it. Cambridge, 1914. Stone courtyards. Cold light through tall windows. The smell of old wood and coal smoke. A world that had excluded Ramanujan his entire life now opening a door to him. Ramanujan produced some of his most important work during his years in England. Hardy worked with him carefully, both learning from Ramanujan and trying, gently, to give him the formal grounding his unusual education had never provided. But England was cold in ways that had nothing to do with the weather. The war had come. The young men of Cambridge were disappearing, called to the front, not returning. The dining halls were half empty. The university carried on with the particular silence of an institution that has lost too many of its people. Into this grieving Cambridge came a man from southern India, strict vegetarian, daily religious observance. 18 months ago, had never left Tamil Nadu. He cooked for himself, but the ingredients he needed had grown scarce as rationing tightened. Verify. Wartime rationing at Cambridge. Some historians argue the inadequate nutrition of those years contributed directly to the collapse of his health. Verify. Ramanujan Biography. He existed at a strange intersection, intellectually closer to Hardy than to anyone he had ever met, and in almost every other way, more alone than he had been in Kumbakonam. Hardy could evaluate his mathematics, but Hardy could not understand times him. Hardy was, by his own description, in times a mathematician's apology, a man who found ordinary human connection difficult. Verify. Relevant. Hardy quotes. They had found each other across an impossible distance, and having found each other, discovered a new distance remained. Mathematics was no longer something Ramanujan practiced. It had become the environment in which he lived. Even when his body began to fail, tuberculosis possibly, or hepatic amebiasis, the exact diagnosis still debated. The writing continued. Verify. Ongoing medical debate. Hardy visited him in the sanatorium. Not knowing what else to say, he mentioned arriving in a taxi with a dull number 1729. Ramanujan replied immediately. 1729 was the smallest number expressible as the sum of two cubes in two different ways. Verify. Well documented. 1 cubed plus 12 cubed equals 9 cubed plus 10 cubed. He was not performing. The numbers simply never stopped arriving. Among the papers he left behind were manuscripts later named the Lost Notebook, after their rediscovery in 1976 by mathematician George Andrews at Trinity College Library. Verify. Over 600 formulas, dense, unproven, extraordinary, that mathematicians are still working through today. He was obsessed, not out of ambition. The mathematics was simply times there, inside him, and the only way he knew how to live was to write it down. The very thing that made him extraordinary was also what made him impossible to reach. He lived so fully inside the numbers that there was almost no room left for the ordinary transactions, rest, nourishment, warmth that keep a person alive. He returned to India in 1919, his health already severely compromised. He was 31 years old. Consider what those 7 years had contained. 1913. Unknown. A clerk's son in Madras with notebooks no one would read. 1914. Cambridge. 1918. Fellow of the Royal Society. Verify. Whether first Indian to receive this honor. Fellow of Trinity College. 1920. Dead. Everything he had spent a decade trying to obtain arrived at almost exactly the moment he no longer had time left to receive it. The recognition, when it came in full, and it came too late. He spent his last months in Madras, cared for by family, still writing. His wife Janaki later described those months, feverish, in pain, and still always writing. Verify. Janaki's accounts from biographical sources. He died on the 26th of April, 1920. Verify. He was 32 years old. Hardy, when asked what his greatest contribution to mathematics was, said without hesitation, discovering Ramanujan. Verify. Widely attributed. Ask calm. But the thing about discovery is that it is always incomplete. You can find something. You can name it. Bring it into the light. You cannot always know what you have found. Ramanujan spent his life searching for people who could understand what he saw. He found recognition. He found fame. He found respect. But understanding is a rarer thing. More than a century after his death, mathematicians are still proving results he wrote down without explanation, theorems he left, with no proof, no working, no indication of how he arrived at them. Verify. Modern applications. Ken Ono. Bruce Burnt. Ongoing work. He was not behind his time. He was simply ahead of it. And that is precisely what makes his story feel so modern. Because most of us are not waiting to be admired. We are waiting to be understood. We carry things that do not translate easily, ways of seeing, interior depths, and spend our lives hoping to find someone capable of receiving them. It is difficult to sit with Ramanujan's story and not ask, how many people are we standing close to right now whose inner world we have not yet found the capacity to reach? And what might it mean to someone if we tried harder to receive them?